going to now shift to the direction that I'd like to see WUDAPT take as to a particular focus, and that'll be modeling. Of course, there's many different ways. Thank you. There's many different ways to use a local climate zone for applications, but here in particular, I'm a modeler, so I would like to bring to you the capability that we'd like to see happen when you have WUDAPT and use it into models at different scales. This presentation is dedicated to Johan. Of course, you just saw a picture of that young man, and it's just such a shame. But anyway, hats off to him. I went to the NCAR, and that's where he was at the time. And he said, Jason, you have a new DAPT product. Why don't you see if you can do it in a worldwide context? And why don't you see if you can do it for not just mesoscale model, but for climate model? And so he provided sticking impetus for doing this on modeling at different scales. So next slide.
You can use the focus.
Oh, I can do that. Okay.
Yeah.
So I'm going to just give you a roadmap of what I'm thinking. Again, this is from a modeling perspective. So let's see, the top three bullets basically why we are interested in moving WUDAPT into the modeling world. And we've gone 10 years now into this program, called the WUDAPT decade, if you like. And we've mastered, or at least gotten to the point where we can get a global map. And we now want to go forward from that. And what do we do? How do we do it as a community? So I struggled with this a little bit, and I thought, test beds. We could set up a test bed, but not in the usual way, but in a strategic way. And that was with the idea that it would be able to tackle problems really for climate and for urbanization. So with that as a context, how to go forward and keep it as a community base. We don't have a lot of funding. In fact, we had no funding in level zero. And I'm afraid that we probably continue to have to do that. But the community comes in and they just simply say, we've got a major challenge. We want to make a difference. And how do we do it? I think that here at this point, that sets a stage for how we set up a test bed. Some unusual way to do this. So here we have test beds which might be city specific, and we can create the using testing our capabilities. And when we find that we can do this in a city specific way, then we can say to the world, hey, we have a proof of concept. We've taken ourselves to the extent where we're satisfied as a scientific community, and we can say, go ahead and go forward in other cities. Let's see, next slide. Oh, I can do that. In January this year, we had a workshop at NCAR. NCAR has a community-based system for modeling at different scales. The first scale was mesoscale to urban, and that's a WRF system. The second one was the global system that Johan worked on, the CESM, and you'll see that there's not yet another system called MPAS, and I'll talk about that just in a little bit. So here's a timeline of the decade of the WUDAPT. Started off when we began the proof of concept in early 2000, in 2012. Moved forward in IAUC, came about and said, yeah, we should get the IAUC community involved, and a lot of history here, and you've heard it already. In 2023, having now gotten the global map, we wanted to see if we can move a global map into models, into WRF, into CESM, and then into the MPAS system. And that's where we are currently. Um, we've made a lot of progress in 10 years, 400 papers at least in a decade on this subject. It's amazing. Um, then we know that we have other products that get into detail maybe a little bit more to support the local climate zone concept. And that's more detailed in terms of the parameters, in terms of, well, a lot of things that go on there. So here's my thought. Set up a pathway. No time limit. Whatever it takes to get a product that can be used to be applicable. And so this test bed is a strategic strategy. It engages you again. You can be involved. You can tell us what your problems are, and then maybe some ideas how to solve it, or just simply say, I got a way to solve it. I don't know what problems you want, but you somehow get together and you figure out how to do this. So we have the community kind of given a challenge and then letting it happen. But there's a lot of work to make it happen. And you've seen this before. What is clear, oh, I didn't write it out. These values of parameters. Some models need other parameters. Some models need less. We can talk about that in a minute. But that's really what is going to be used to drive the models as inputs. Oops, I need to talk. Thank you. So the three models that we focused on at the workshop was the WRF model. It has an urban component. It's got a single layer model. It's got a couple of multi-scale parameters, systems, the BEPT and the BEPN. But now we want to ingest WUDAPT, the global product. And I can tell you now, and there are people here or elsewhere in the conference who are making it happen, WUDAPT will have, WRF will have in an official release in the fall, a community-based supported system with the global mapping of local climate zone in it. So that is amazing accomplishment. Okay, so this is how they're doing it, and we'll go into the details there. What about the CESM? Here's something very interesting. The CESM, in the use of CMIPS, which is used in the IPCC, that's the only model, the global model, that has an urban component in it. So it was good to have ability to work with the NCAR folks. They'll support this. This is going to be supportable community-wise. And here's what we do. Ning, I don't know if Ning is here. He inspired this to take place in the following way. There are in CMAP, not CMAP, the CLM 5 classes, land classes. And there's an urban class here. And it had about three. It had four, I was right. Okay, well, it had four categories. We simply replace it with the local climate zone and the table lookup, which has these values. The problem will be judgment call and so forth as to how we proceed, but it is proceeding. I will show you this slide, but I won't go into it. Basically, it's the design of how we're going to implement this in CESM. It is being proposed to NCAR. They actually said they would go ahead. Lei Zhao is chairing another session. He will be the, how do you say, Hunter in NCAR. And we will go through a lot of procedural things to set it up for implementation. And that's work to come. Okay, so the next one is this. You are going to see the availability of the MPAS system, a model for prediction across scales. It's a big project at NCAR. And if it's going to be NCAR supported, it's going to be community supported. So again, you're going to have capability now with this kind of a framework. I can't go into that, but there is a lot of literature on it. For a, I used to work at EPA, and there was an interest in their quality. Can we use MPAS for equality? So, wrong. So anyway, tie in the MPAS system with another system called CMAC, which is Community Model Air Quality System, and and it's been done. They've linked these two together and created a capability to get a global map of ozone. Of course, with CMAC, you can get anything else, particulates and so forth. You can deal with wildfires and so forth. So there's a lot of capabilities here. And let's see, this was presented at the workshop, sorry. So we find that now we can have 3 different systems to go forward with. There can be others, but we have this capability from WUDAPT to move it into creating model-ready data, so you can use it for different applications. There are other things that we do in WUDAPT. It's a tiered system, and so we've got developments in trying to improve on the form-based parameters. And if you can digitize real data, you can then calculate these parameters, and you can either put it into your local climate zone and substitute it in there or whatever. But that's a capability that you could have. And we'll have a tool there that will take this kind of data and move it forward. That will be a test bed. That will be a test bed by itself. And we will talk about that in a minute, hopefully. I don't know if we have time. Probably. Next one. Okay, so that particular methodology, we call it the digital synthetic tool. On the far left, on the top, is your ground truth. The digital synthetic city tool, as of late last year, this is Chicago from off of the ground truth. And you can see that for some of these parameters, an area, weighted building height, this is the statistic, nearly 98% and 95%. And we can improve on that even. So it's going to happen. We are going to have that capability. So, test beds. It's community collaborative. We want to utilize all the different kinds of methodologies we have into these modeling tools. There are many. Here are some examples of where we might go with this. There's a UWRF that we're going to try to go. Oh, I have to stop.
Yes, you do.
I do. Okay. Let's see. If I can go to this one. We saw this. This is how I introduced this topic. And these are test beds that we're starting up. We're going to link with the IFLs from DOE. There's 4 cities. You see them there. And it's going to happen. We're sorry. We're going to have a test bed for street and grid modeling, and that's happening. So I want to invite you to the following. We have a special issue of urban climate. The deadline is coming up, but we're going to try to move it back a little bit. So if you have an interest, and get your papers to me or to the urban climate. Let me know, and then go forward. Publishing in a special issue. And I think I should stop there.
Thank you very much. Sorry, I had to cut off Jason.
No problem.
Just in time.
Yeah, I do.
I can't take any questions. But what you're going to see in the next series of presentations is the application of local climate zones to a variety of different areas. So, the next speaker